Alright, today we're going to talk about how to balance half reactions. So, in balancing a half reaction, the first thing you need is a half redox reaction. The half redox reaction that we'll be working with today is here. This is a reduction reaction. The oxidation number of this Cr2 is actually +6 and it goes to +3, so it's been reduced. The way I know it goes to +3, a little review of assigning oxidation numbers. I know that it is +6 because oxygen is always -2 in a chemical reaction. 7 times -2 is -14. And remember, because this particular compound has a charge of 2-, we want to end up with a charge of 2- overall. So, this chromium needs to end up being +12, so that we have 12 minus 14, leaving us with a 2- charge. So, here we need to figure out what the charge on a single chromium is because we have 2. So the question becomes 2 times what number is +12? And that answer is +6. Okay, so we now know that this is a reduction reaction because chromium goes from +6 to +3. So the next thing we need to do is follow these 5 steps. So first, balance the central atom, usually one that is not oxygen or hydrogen. In this case, it's going to be the one that goes through the reduction or oxidation. Because chromium is the one that is reduced, chromium is our central atom. So the first thing we need to do is balance our central atom. So I'm going to get rid of this arrow and draw a slightly smaller one because we're going to need some room out front to balance this. Alright, so here's our reaction arrow. And we need to balance this chromium. I have 2 chromiums on this side, Cr2, but only 1 chromium on this side. So I need to put a 2 out front. Alright, rule number 1, check. Rule number 2, I need to add water if needed to balance oxygens. I have 7 oxygens on this side, no oxygens on this side. So I need to add 7 H2O molecules. Great. Now my water is balanced and my oxygens are balanced. But with these problems, anytime you fix something, you create another problem for yourself. So in this case, by fixing the oxygen problem, I've created a hydrogen problem. I have an overabundance of hydrogen on this side and need to fix that. In order to fix that, we add hydrogen ions. So this side has 14 hydrogens, 7 times 2 hydrogens in water. So on this side, we need to add 14 H+ ions. So now my hydrogens are fixed, but unfortunately I've created a charge problem now. So the charge problem comes from the fact that, sorry, I'm going to erase a few things to make it more clear what we actually have. Alright, so on one side of the equation we have 2 times a +3 to give us +6 overall. These coefficients multiply the charge as well. So on this side of the equation I have a 6+ overall charge. On this side of the equation I have 14 H+. If one H is +1, 14 of them is +14. So I have 14+ on this side, but I also have 2-. So I need to add to that 2-. And when you have 14 and you add to it -2, you end up with 12+ overall. So now we need to figure out how to turn 12+ into 6+. The last step before you check is you add electrons to balance charge. So each electron has a -1 charge, so in order to turn 12 into 6, we need to add 6 negative charges. So on this side, we have chromium 2 plus O7, so this is a dichromate molecule, 2 minus, plus 14H plus 6 electrons, all turning into 2 Cr3 plus ions plus 7 water molecules. So that is balancing a half reaction. We're going to do a couple more examples of half reactions. So I'm going to erase this reaction and do another one. I'm going to cover this up. And so this will be example number 2. Alright, so this half reaction is going... Alright, so we're going to do another example. This will be example number 2. With example number 2, we have nitric acid turning into NO2, so nitrogen dioxide. What we're going to do here is we're going to start by first balancing the central atom. Fortunately, in this case, we have 1 nitrogen on this side and 1 nitrogen on this side. So our reaction, or at least the central atom, is balanced. The next thing we need to do is add water, if needed, to balance the oxygens. Well, there is a need because we have 3 oxygens on this side and only 2 oxygens on this side. So what I'm going to do is add 1 water molecule, because to fix oxygens you always add water. Each water molecule has 1 oxygen. So now I have 1, 2, 3 oxygens on this side and 3 oxygens on this side. But like any balancing of half reactions, when you solve one problem you create another. So now I have 2 hydrogens on this side and only 1 hydrogen on this side. The way I fix that, step number 3, add hydrogens if needed to balance the hydrogens. So I'm going to add a hydrogen ion right here. Now I fixed my hydrogen problem, but because I fixed one problem I've created another. Now I have a charge problem. Everything's neutral except for this one charge. So this whole side of the equation has no charge. This particular compound has no charge, but this hydrogen has a 1 plus charge. So we're going to have a 1 plus overall charge on this side. The way we fix that, add electrons to balance the charge. Electrons are very handy because they'll solve our charge problem without creating a problem of their own, because they don't have mass. So really all they are is just a negative charge. When we add one negative charge to a positive charge, they cancel each other out and our charges are fine.